Okay, part 1. Completely ionized is only for strong acids, so it's not for all acids. Then pH less than 7 is correct. They do not react with all metals. They only react with reactive metals. So this is not completely correct either. Then they are good conductors of electricity. This is true because they will produce ions. So question 1 is not 2 and 3. Were you paying attention just now? Ionic equation for neutralization, there is only one answer. Okay, I would like to go through question 1, question 3, question 4. Question 1, I talked about it just now. So the first option, we have strong as completely ionized is only strong acids, not all acids. Their pH is less than 7 is always correct. They only react with reactive acids, not all metals. Then they are good conductor of electricity. Because when it dissolves in water, they produce ions to conduct electricity. So answer is actually 2 and 4. Okay, then 3 is an oxides question. When you blow into a straw, okay, when you do that, right, you blow carbon dioxide into the water. So what happens when carbon dioxide is in water? Carbon dioxide is an acidic oxide. Yes. Number 4. Number 4, the hint is down here. So aqueous solution of potassium carbonate. Aqueous means there's water. And water will break up into H plus, OH minus ions. And your potassium carbonate will break into this and this. So there are 4 ions. This one. He has an acid of pH 2. Then he added this into the acid and test for pH again. So what happened is if you add an acidic substance to the acid, it will become more acidic and the pH will drop. If you add a neutral substance to an acid, the pH will remain the same. Then if you add a base to the acid, the pH will increase. Based on that, do you think you need to reconsider your answer for question 6? Okay, correct. Which substance do not produce copper? Yeah, copper does not react with acids, dilute acids. For question 7, right, even though I have crossed out, but given the info down here, can you guess the answer? Just make a wild guess. Okay, fair enough. If let's say that I have compound W, then when I throw it into water, it will break into 1, 2, and 3 ions. Then what would the answer be? Okay. 9 is D. 9 produce hydroxide ions when dissolved in water. React with metals to produce hydrogen. Okay. 9 is D is correct. 10
is B.
pH of the liquid in a beaker is 7. 10 is D. Why must it be a pure substance? It's a color solution that does not conduct electricity. You won't know whether it's a pure substance or not. because it can have pH 7 and then there are still impurities inside. Then it is not a pure substance, but it still has pH of 7. Then the pH value, so you have to go back to your definition of pH. pH means it's neutral. So when it's neutral, what happens to the number of ions, hydrogen ions and hydroxide ions?
Hydroxide ions are equal.
Yeah. So actually, it's this one. 11, 12. All of the above is not correct. This is testing you on oxides. They're asking you which one. Okay, it's a combination of acids and bases and also oxides. So if it produces H plus ions, that means it must be an acidic oxide. Hint, 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 hint. Very big hint there.
Dioxide and carbon monoxide.
So oxide. So they are testing you acids and oxides. So this one, H plus ions. Then the oxide must be acidic oxide. So then you take hydrogen chloride. Hydrogen chloride when dissolved in water will give you like that. So this one correct. Then you have to go to the rest of the oxides. So 1, 2, 3 oxides here and decide whether they are acidic oxides or not. So carbon monoxide is 1 oxygen only. So it's a neutral oxide. So this one, bye-bye. Then you're left with carbon dioxide. Carbon dioxide has 2 oxygen, so carbon dioxide is an acidic oxide. Then you have nitrogen dioxide. Is this dioxide, right? Means it's more than 1 oxygen. It has 2 oxygen, so nitrogen dioxide is also acidic. Then back to nitrogen. Nitrogen is an unreactive gas. So being unreactive, it will not dissolve in water. It will not do anything with anything. So it does not produce hydrogen ions at all. So this one is also out. So then you would have 2, 4, and 5. B. Your first answer is correct. The first answer you put just now was correct. If you read the PowerPoint slides that I have, it's written somewhere that calcium oxide, calcium hydroxide are used to decrease the acidity of the soil. It's only the calcium based calcium compounds that are used. Sodium hydroxide is too alkaline and it is soluble in water, so you can keep on adding and adding and adding, and you cannot detect that you have added too much of it. Ammonium nitrate and potassium chloride, they're all neutral, so they will not decrease the acidity of the soil. Okay. 16, 17. Two substances P and Q are mixed in the beaker and have an initial total mass of 100 grams. And the mass of the beaker and its content are recorded at regular intervals and the results are as shown. Then they ask you what could P and Q be? What could P and Q be? So there are some things you should note down here. Question shows you that the graph is horizontal line. And then down here is mass. A horizontal line means there's no decrease in mass. When there's no decrease in mass, it means that nothing escapes. Nothing escapes means there is no gas formed. Because when gas form, right, it will just escape into the air. Then you cause the mass of the beaker to become lighter and lighter because the condense goes missing. So in that case, since no gas is formed, so out of your 4 choices, the 4 options, you must look for the one that has no gas involved. Which out of the 4 options does not produce a gas? C. Okay. The next one, you write answer B. What color will be observed at pH 6 if equal volumes of these 3 indicators are mixed together? pH 6. Okay, so you write B. So let me work out this. At pH 6, color change at 7, so it will be yellow. Then yellow. Then at pH 6 is colorless. 18. Acidic oxide. Can zinc form acidic oxide? Zinc is okay, zinc will form zinc oxide, and zinc oxide is an amphoteric oxide. And metal oxides only form basic oxides or amphoteric oxide. So cannot form acidic oxide. So option C is out. So that means all metals are out. So these 2 are out. Then you are left with silicon and nitrogen. Because nitrogen can form NO and NO2. So NO is 1 oxygen atom. Yeah. Acidic oxide dissolve in water to form acid. Yeah. It dissolves in water to form both acidic question mark. Then dissolve in water to form alkali. Not true. Most metal oxides, right? Most metal oxides don't dissolve in water. So these 2 is not very true. So that is not the best answer. So dissolve in water for this, okay. React with phase to form salt and water, this is fine, and this is fine. For acidic oxide, all options are correct. Then amphoteric are insoluble in water. They are unreactive. This one unreactive with acid or bases. This is wrong, so this is struck out. So then react with both bases and acid to form salt and water. This is correct. Then reacts with acid to form salt and water. This is also correct. Basic oxides, they will have some that dissolve in water. Not all insoluble in water. So this is not entirely true. Because you have your sodium oxide, potassium oxides, they all dissolve in water. So out of these 4, right, then D will be the best answer. 22. Then after that, we go to question 1. What about question 23? Insoluble basic oxide. You might want to refer to the slides again. I highly encourage you to go look at the slides again if you cannot remember. So 23. Which oxides react with sodium hydroxide to produce a salt? So they're asking you which oxide reacts with a base to produce a salt. So only amphoteric and acidic oxides will react with sodium hydroxide. So you have to go to that list and look for one of them that fits the criteria. So which one is the answer for question 23? C. You are looking for an amphoteric oxide or acidic oxide. So acidic oxides are, if it's acidic oxide, then it will be non-metals. Then if it's amphoteric, it will be only lead oxide, zinc oxide, and aluminum oxide. Do you want to reconsider your answer? Yeah, zinc oxide. Okay. Let's go to the next one, the question 1. There are certain questions that I don't want you to touch. So F, let's not do it. Then this one, I also don't want. Then take note, this one, they say an insoluble basic oxide. Basic. Acidic oxides are non-metal oxides. So 1A, you are looking for an insoluble basic oxide. Basic oxide. Magnesium oxide. Yeah. Yes. Number 2, part B, a neutral oxide. Yes. Able to dissolve in both acidic and alkaline solution. Yeah. Part C, commonly known as quicklime. That one. Calcium oxide. Yes. Cause of acid rain. 2 more. Gas at room temperature and pressure and produced from combustion of one of another oxide. Combustion, that means you burn. So you look for 2 oxides that are related here, which is this and this. Gas at room temperature and pressure, this one, okay. So if you notice carbon monoxide and carbon dioxide, if you combust carbon monoxide, you will get carbon dioxide. So your answer for G is also carbon dioxide. Okay. 3 and 4. Let's do 3 first. No. magnesium oxide cannot dissolve in water. Only group 1 metal oxides will dissolve in water. Nitrogen monoxide. Okay. This one, group 1 metal, that means it's lithium oxide. So what about F and G? The solid F, right? Part F, a solid that's insoluble in water but dissolves in aqueous sodium hydroxide. If it's insoluble in water, then it's not an acidic oxide. It is not an acidic oxide because acidic oxide dissolves in water. But then it states that it dissolves in aqueous sodium hydroxide. That means it is something that can react with a basic, it can react with a base. Something that reacts with a base and it is not acidic. So when that happens, it's this or this. All this disappears. Because if it's not acidic, that means it must not be a non-metal oxide. So then that means it's a metal oxide that dissolves, that reacts with sodium hydroxide. So a metal oxide that reacts with sodium hydroxide must be an amphoteric oxide. So as an amphoteric oxide, that means you would end up with either this or this. So the answer for part F is either aluminium 3 oxide or lead 2 oxide. Then something that dissolves in water to form acidic solution, carbon dioxide is correct. Like that. So we have question 4. We have 4 indicators. I will not want to touch this question. So you just do part A. They say which indicators, that means there's more than one answer. E is correct for another answer. Okay, A part 1. Which indicators are yellow in pure water? So pure water is pH 7. So I will take a ruler and draw down pH 7. Then where the pink line cross and is yellow is the answer for A part 1. So you got this and this, which is yellow. So you have part E and then part A as the answer. That's for A part 1. A part 2, it says which indicator shows the same color in sodium hydroxide? So sodium hydroxide is strongly alkaline, so your pH will be at 12 or 11. So I'll use green right now, green color. So at pH 11 or 12, I draw a line down again. Then they say which indicator show the same colors in sodium hydroxide. So for this case, this is yellow, this blue, this is blue, this is pink, and then this is blue. So which indicator shows the same color? For part 2, there are 3 blues. So it's B, C, and E. 3 answers. Then part 3, which indicator shows the same color in carbonic acid? Carbonic acid is a weak acid, so weak acids tend to have pH around 4 to 5, 6. 4, 5, 6, around that. So, got it. So each indicator shows the same color in carbonic acid. So you have one which is yellow, this one is yellow. So it's B and E. Then there's another answer that's possible. Possibly this one, carbonic acid. I think it's still 5 and 6. So the answer should be just B and E. Then number 4. Which indicator shows the same color in carbonic acid and sodium hydroxide? So I'm going to erase whatever I have here. So carbonic acid is at this is at 5, that we mentioned earlier. Then sodium hydroxide is around 11 or 12. So let's put it at 12. Then it tells you that there is one indicator that shows the same color for both carbonic acid and sodium hydroxide, which is this one. Because my 2 lines cross, my 2 pHs cross the same line, and it writes yellow there. So answer A. Okay. Okay. So now I have a whiteboard down here. I want to check your, okay, let's say checks on valency. So sodium, potassium, calcium. I can't remember all of them, so I just have to write down a few. Okay, I have some ions down here. Can you write down the valency or the charge of the ion? I can't see this one. Is this plus or minus? This one is not correct. Copper is 2 plus, iron is 2 plus or 3 plus. So depends on question if they say iron 2, iron 3. Okay. Let's have you balance some equation before we let you finish the lesson. Okay. Let's do this. And this. Let this question. Okay, never mind. You just continue the question. Copper carbonate plus HCl give you copper to chloride plus carbon dioxide plus water. Copper, copper to carbonate. Your question not balanced. This is not balanced. This one also not balanced. This one is lead carbonate like that. Because lead is 2 plus, CO3 2 minuses. Like that. So it's just then your copper carbonate, copper is 2 plus, carbonate is 2 minus. So you become COCO3 only. So if it's like this, then it will be HNO3, then gives you lead nitrate. Your lead nitrate is correct. Plus CO2 plus water. Then 2 here. Then one carbon. Then 2 balance here with hydrogen. Lead balance is lead. Then you have 3 oxygen here and 3 oxygen here. Then this copper carbonate like that plus HCl gives you CuCl2 plus CO2 plus water again. Then copper go with copper seed like that. Then 2 hydrogen with 2 hydrogen, 1 carbon with 1 carbon, 3 oxygen like that. Okay, can you do this one 5b part 1? Okay, 3a part 2, just do that one question. Okay. I remember. Yeah. Okay.